Hi, this is lab practice of team number 2, and we're gonna demonstrate the Charles lab. All that we need is first warm water with ice, a glass bottle, and a balloon. First, we're gonna put our balloon in the glass bottle, like this. Then we put our glass bottle in the warm water. And now we wait. Now this. Now we put our bottle in ice. What happened and how this is relation with the Charles law? Well, my parents will gonna explain that.
Hello, my name is Adrian Giovanni, and I'm here representing Team 2 to make the introduction of about the Charles Law experiment that we were assigned to do. And in this experiment, we're going to be explaining a little bit the laws that Charles proposed about gases.
Well, for the purpose and the research question about our lab practice will be, well, the purpose is that we want to learn how the Charles law works, not only in theory but in real life. And what they're going to learn with this is that the volume of a gas is directly proportional to the to the absolute temperature when the pressure is constant.
Now, when it comes to the hypothesis of this lab report, is that when we heat up a gas, the molecules will start to grow faster, making it very unstable, and also making the gas a little more like dry up. This also causes that molecules start heating up and start colliding with each other inside the gas molecules. This also causes that the recipes inside wall start heating up as well.
The variables will be, well, the independent variable is the pressure and the temperature. The dependent variable is the volume, and the control variables are the materials, the balloon, the glass bottle, the warm water, and the ice. What are the materials that we use for this practice? Well, the warm water, cold ice, a glass, a bottle glass, and a balloon.
Our method consists of two bowls, one bottle, one glass bottle, and one balloon. In one bowl, there is warm water, and in the another one, there is water with ice. So we put the the balloon on top of the bottle, of the glass bottle, and then we try it on the two bowls. When we put the bottle with the balloon on the warm water, the balloon starts the air starts to go into the balloon, making the balloon inflate. But what happens if we put the glass bottle onto the bowl with ice and water? Well, when we do this, the balloon that it's inflate because of the warm water starts to deflate, slowly starts to deflate.
During the experiment, we observed that when the bottle was placed in a container of hot water, the balloon began to expand. This occurred because the air inside the bottle heated up and increases its volume. Then, when the bottle was moved to the container of ice water, the balloon began to deflate. This happens because the air cooled and contracted, decreasing its volume. Our observations was that in hot water the balloon expands, and in cold water the balloon contracts.
So, this law is showing us how it works because this law states that when a gas is heated, the volume will increase, and when it's cooled, the gas, the volume will decrease as long as the pressure stays constant. The gas on the bottle is starting to heat, so the gas particles will start to move and spread in the balloon and the bottle, making the balloon bigger. And in the water with ice, the particles starts to move slower and get together.
So, in conclusion, this demonstrates the Charles law. That the Charles law states that at constant pressure, the volume of a gas is directly proportional to its absolute temperature. This means that when the temperature of a gas increases, its volume also increases. At the same way, when temperature decreases, the volume decreases. Our results were good since the balloon inflates with the heat and deflates with the cold. We also learned how gases react directly to temperature changes, which explains everyday phenomena.